So let's say they've given you f of x, which is equal to the absolute value of x minus 1, let's say plus the absolute value of 2 minus x. They've asked you to sketch this function. Now you can see that this function has got two absolute bars. So for you to be able to sketch, you need to redefine. So you are going to redefine the function. Okay, so that's the important thing. You are going to redefine the function. Now how do you get to redefine the function? Maybe that should be the question. So to redefine the function, if you want to sketch absolute value function, which are they've given you two of them, equate this one to 0. Richard, what are you going to get as the value of x?
Positive 1.
Yes, so x is going to be equal to positive 1. And then when you equate 2 minus x to 0, you are going to find that x is equal to positive 2. From here, I'm going to write a table of values. If you've been attending our classes by now, you should be familiar with table of values. Okay, so here I have got what I equated to 0. I equated to 0 x minus 1. I also equated to 0 2 minus x. Okay, so the value we found is 1 and 2 when we equated them to 0. So when you equated x minus 1 to 0, you found positive 1. So meaning that if I get any value of x above a 1, like a 2, I put here 2 minus 1 to be positive. So this will give us positive. Now when I get any value crossing 1, then we're going to get negative. For example, put 0 here, 0 minus 1 to be negative. When you equated 2 minus x to 0, you found a 2. So when you use any values of x greater than 2, like a 3, put here 2 minus 3 to be negative. Immediately cross 2, it to be positive. Yes, Sherry. Shekaina.
Sir, can you just repeat on the table?
Okay, so what we've just done is we've gotten this factor, that's the one we've put here. Also gotten this factor, that's the one we've put there. And then the values that we got after equating them to 0, those are the ones we have gotten. Now I always start with a smaller one because this is a number line. So for this factor, remember when you equated it to 0, you found 1. If you use any value of x greater than 1, meaning that this side of 1, you put where there is x there. Like a 2, 3, 4 to give you positive. So as long as you are talking about values of x greater than 1 for this factor to give you a positive value. And then as long as you cross this one, you go to this direction. The sign is supposed to change. If going forward it was giving you a positive, then go in the other direction to give you a negative. Same with this one. When you equated it to 0, you found 2. So what happens if you use values of x greater than 2 for this factor? For example, again, get a 3, put it here. 2 minus 3, we know that's a negative, right? So that is why I've put a negative here. And meaning that immediately you cross the 2, you start going in this direction, it always gives you positive. Is that okay?
Yes, understood.
Alright. Now from here, we are going to redefine the function. So we say f of x is equal to, so you are able to see that you have got three regions here, right? You have got values of x smaller than 1, values of x between 1 and 2, and values of x greater than 1. So I can shade here if I want, and then I can also shade here if I want. The aim of shading is just to make sure that if I connect what I've not shaded with that what I've shaded, they are going to join. Or if I want, I can shade everything. There's no crime. But just make sure that the intersection of these two, one has to be shaded. The intersection of these two, that one has to be shaded. So whatsoever you shade, it's up to you. Or you can shade one or you can shade both. So if I want, I can shade this. And what you need to know is that when you shade, that means you are going to, if you are talking about greater than, then it will be greater than or equal to for something that you shade. Something that you've not shaded, it is just the greater than. And then when you shade, maybe if it's less than, it will be less than or equal to something that you've not shaded, it will just be less than. Because something that you've just shaded means you are including that value. So we have got three regions. Pay attention. Okay, we have got three regions. So I'm going to redefine. I'm going to write this function like this. I'm going to write the first factor. I'm writing this same thing you are able to see here. Just the same thing. We have got x minus 1 plus 2 minus x. Now notice that I'm not putting it in absolute bars, but I'm putting it in what? In brackets. The space is going to be small here, so let me make it like this. Okay, I'm writing x minus 1 plus 2 minus x. I have not changed anything, so I'll say this is for values of x. I'll start with here, values of x smaller than 1. So I'm going to say that x is less than 1. And then I'm going to write the function again, just the same function you're able to see. I'm just removing the bars. It's x minus 1 plus 2 minus x. And then I'll say this one is for values of x between 1 and 2. Okay, so since here I just said less than 1, now I want to write values of x between 1 and 2. How can you write that condition? I'm going to say 1 is smaller than x and x is smaller than 2. Then you're talking about values of x between 1 and 2. Okay, 1 is smaller than x is also smaller than 2, meaning that those values of x we're talking about are supposed to be between 1 and 2. So that's what I'm going to write. 1 smaller than x and x is smaller than 2. But since I didn't include 1 here, then I'm going to include 1 here. Or if I want, I could have included 1 here. It's all up to you. Even if I include both like this, it's not a crime, right? And then I'm going to write another one, just the same one you're able to see here. I'll write it again, x minus 1 plus 2 minus x. But this one I'll get values of x greater than 2. So I'm going to say x is greater than 2. Now since I didn't include 2 here, then I'm going to include 2 here. So I'm going to say greater than or equal to 2. So before I proceed, do you have anyone who is lost here?
I'm not clear, sir.
What are you not clear about?
Approximately everything.
So all I'm writing is, yes, Mr. Richard.
Yes, my only question is if you have included 2 in the second equation. If I say x is greater, x is less than the second equation. If I include
Yes.
2, is it? Can I say it is only greater on the third equation?
So yeah. So if you want, you just write this. You include x there, and then here just say greater. It's up to you. Or even if you include it there, it will not make no difference. So the only reason as to why you are including there is just to make the function continuous. Like it doesn't, it's not supposed to be cutting.
Okay.
So Sherry, are you the one who asked the question? Who asked? Oh, it is Tina.
Yes. Yes.
Okay. So all I'm writing is this same equation here. Okay. This is what I'm writing, but instead of me putting absolute bars, I'm just putting what? Brackets. So just write this same equation 3 times. Okay, but don't put absolute bars, just put brackets. And then at the end, just put the region you are talking about. You have got values of x smaller than 1, values of x between 1 and 2, and values of x greater than 1. So these are the conditions which I've written at the end here. For one, I've picked for values of x less than 1. For the other one, I've picked values of x between 1 and 2. The other one, I've picked values of x greater than 2. Just that, but the same thing. I've just written the same thing 3 times, but I've just picked those 3 different regions. Is that okay? Are we okay?
Where is the greater than and the lesser than or equal to coming from?
So I said if you want, you can make. So you see here it is here in relation to 1, x is just less than, okay? But if you look at the second one here, I said if this one is just less than, then make this one less than or equal to, so that the function is going to be continuous, like it shouldn't break. Because if I say this one is less than, and then the other one I just say is greater than, meaning that these 2 points here, they are not going to be meeting. Okay, so we need the lines to be meeting. So if I say this is less than, like that, then I need to say another line continues to join from there. I don't know if that's so. That's the only thing. Is that okay?
Yeah, understood.
Okay. Now from here, when you look at values of x less than 1, okay, values of x less than 1, you are talking about this region here. These are values of x less than 1. Okay, so if you look at the factor x minus 1 itself, for values of x less than 1, this is x minus 1. Have you seen its sign for values of x less than 1? Can you see the sign? Are you able to see that sign? What sign is that? Share, Shekine.
That's a negative.
That's a negative. So for values of x less than 1, okay, for values of x less than 1, I'm going to put a negative on x minus 1. And then for values of x less than 1, what's the sign for 2 minus x? What's the sign you're able to see there? What's the sign?
Positive.
Positive. So I was supposed to put a positive here, but you know positive times positive doesn't change anything, so I'll not put it there. And then if you go for between 1 and 2, between 1 and 2, you've seen that both are positive, right? Meaning that I was supposed to put a positive here and also a positive here. But positives don't change even anything, okay? They will not change anything. And then for values of x greater than 2, you can see that the 2 minus x is what? The 2 minus x is what?
Negative.
It's negative. So I'm supposed to attach a negative in front here. Please, in front, okay? In front. And then the x minus 1 is positive. So I'm supposed to attach a positive here. Remember, then this was positive. So just simplify this. So this is going to give you, you start distributing this negative to the inside. So I'm going to have negative x plus 1, and then positive times 2. Shekinah, yes?
Where did you put the negative? In the equation?
Yes, I've put it here. You put outside the brackets. Okay,
Okay.
so I'll distribute this positive, so that will be positive times 2, that will be positive 2, positive times x, that will be, I mean positive times negative x, that will be negative x. This is for values of x less than 1. And then positive for the second part, positive times x, positive times negative 1, negative 1, and then positive times 2, that will be 2, positive times x, negative x. This is between 1 and 2. And then positive times x, this is going to be positive x, positive times 1, negative 1, and then this negative times 2, that is going to be negative 2, and then negative times negative x, that will be positive x. This is for values of x greater than or equal to 2. So this continues. Now we can add like terms. Okay, this is 1 plus 2, that is going to be a 3. And then negative x minus x, that is going to be positive, not positive, that's a no, negative 2x. This is for values of x less than 1. And then here I've got positive x. Okay, that's positive x. This is negative x. They are going to cancel. All right, and then I've got negative 1 plus 2. That is going to give you positive 1. This is for values of x between 1 and 2. And then if you got down, you have got x plus x, which is a 2x. Then negative 1 minus 1, that's a negative 3. This is for values of x greater than or equal to 2. So this thing you're able to see here is what is called a redefined function. So if a question can redefine the function, this, then you have redefined the function. So you can't sketch this direct. You can now sketch after redefining. So I'm going to remove this region and then we can sketch.
Sir, can you just retain what you rubbed there? If at all it's possible. I didn't copy. Thank you.
Uh, you can still refer to the video even if you've not copied. I'll send the class.
Okay, no problem.
All right. Okay, so now here, remember when you equated this one to 0, you found a positive 1. So I'm going to put a positive 1 here. And then when you equated the other one to 0, you found a what? That was a positive 2. Put a positive 2 there. Now, this is telling you that this equation you're able to see here. Look, this equation on top is only working, like it's only working for values of x smaller than 1. Okay, smaller than 1. Take note of that. It's only working for values of x smaller than 1. So start with a 1 itself. Okay, get x to be 1. Get x to be 1, you put here where there is x. So that is going to be 2 times 1, which is a 2. 3 minus 2 is a 1. Meaning that when x is 1, y will also be 1. So I'm going to have a coordinate here. Now notice that I've put a circle. I've not shaded that circle. Why? Because we are talking about values of x less than 1, not less than or equal to, meaning that we are not including 1 itself. That's why I've put an open circle there. Okay? And remember, this one is only varied for what? Values of x smaller than 1. So if you used 1, go to a value of x smaller than 1, you can go to a 0. Go to a 0. Okay? You get a 0 put in this function. 2 times 0 is 0. 3 minus 0 is a 3. So I'm going to come somewhere here. So I'm going to see that you are going to have a coordinate 0, 3. It is going to be there. Now, since this is a straight line, 2 points are enough. Just join these, making a straight line. So this line is going to go like this. You will not go to values of x greater than 1. Like you can't exceed 1, you start going down. No. This function is only valid for less than 1 numbers of values of x. So this function will continue going like that. And then between 1 and 2, for between values of x 1 and 2, the only y value you are finding is what? 1. Okay? Meaning that when x is 1, you are finding 1. So you are going to have 1, 1, which is at this very point. So I'll now shade it because it's a coordinate for the second equation. And then when x is 2, you still find 1. Okay? So we are going to put again another dot here. It's supposed to be an open circle because you can see that 2, we are not including it there. It's just less than, so I'm going to put open circle. In other words, every time when x is between 1 and 2, the only y value you are going to be seeing is 1. Meaning that the line that you are going to have is a line that is down like this. As long as you are between 1 and 2, the only value you are going to find for y is 1. Okay, and then you go to the third equation. When x is greater than 2, the only equation you're using is 2x minus 3. Okay, So you start with 2 itself. Please always start with the number itself that you've been given. So get a 2 you put here. So it will be 2 times 2, which is 4. 4 minus 3, that is a 1. So we're finding that when x is equal to 2, y is going to be equal to 1. So it gives you this first same point here. But now we're going to shade it because we're including it. Why are we including? Because this is greater than or equal to. Okay. And then this one, remember, is only valid for values of x greater than 1. So get another value greater than 1, like a 3. Put here 2 times 3 is a 6. 6 minus 3, that is going to give us what? A 4, isn't it? Okay. That is going to give us a 4. So somewhere there. So 2 times, no, not a 4.
Not a 3.
It's supposed to give us a 3. So I was thinking this is a 2. Okay, so it's to give us a 3. So we're going to have a coordinate 3 comma 3, which is somewhere there. Okay, and then join these points. Just from there, join. So the graph will continue going up like that. So this is how you draw a graph of an absolute value function where there are two. So this is a graph. And they carry good marks. Nice marks. So this is how it's supposed to be. Alright, let's look at one more example. So just explaining this, I've taken 20 minutes to explain. One question. So meaning that for the next one, I'm going to go a bit of quick because we've seen the procedure. Alright, so Shekaina, who is confused, pay attention on this one. Let's say I've got the absolute value of x minus 2, and then let's say minus the absolute value of 2 minus x. Okay, like that. Now, the only way you can sketch this function is first redefine it. To redefine the function, I'm going to equate this to 0. We're going to find that we're going to find x being equal to give us a positive 2, right? So let me actually change this so that we have different values instead of one value. So let me say we are going to have x plus 2. Okay, like that. So equate this one to 0. We're going to find that x is equal to positive 2. Yes, Mr. Richard?
So, does that sign in between the absolute value affect the solving, or it doesn't?
Yeah, it will affect the way we're going to be redefining it.
Okay.
Yes. So equate both to 0. We're going to find that this first one will give us positive 2. The next one will give us a negative 2, right? And then I'm going to draw a table. Shekaina, is this okay when they're equating to 0? Is that okay?
Yes, it's fine.
Okay. So I'll now get those factors which I've equated to 0. We've got x minus 2. We also have x plus 2. So the values we've gotten is a negative 2 and positive 2. Please write the smaller one first and then the bigger one. So x minus 2, when we equated to 0, we found what? Positive 2. Meaning that when I use values of x greater than 2, like a 3, I put here to be positive, right? Immediately I cross the 2 to give us negative. When we equated x plus 2 to 0, we found negative 2. What happens if I use values of x greater than negative 2? I put here, like a negative 1, or a 0, or a positive 1. It will give us positive. Immediately I cross negative 2, it becomes negative. Okay? And then I can now redefine. So I'm going to say f of x is equal to, I'll write it 3 times. I'll first write, now I'll not put absolute bars, I'll put brackets, x minus 2 minus x plus 2, and then x minus 2 minus x plus 2. Please get the sign on the middle the way it is. Basically, you just get everything the way they are. The only thing changing is you're not putting absolute bars but brackets. And then the first one should be valid for values of x smaller than negative 2. So I'm going to say x is less than negative 2. If I want, I will send less than or equal to. And then the next one, I'm going to get values of x between negative 2 and positive 2. Okay, so I'm going to say negative 2 is less than x, which is less than positive 2. Now, since for the first one I included negative 2, so it's okay for me not to include negative 2 here. Okay, and then for the next one, I'm going to talk about values of x greater than 2. So I'm going to say x is greater than 2. Since I didn't include 2 here, then I can include 2 on the next one. Or if I wanted, I would have included 2 on the other one, the same one on top. Yes, Pagzena.
Sir, please kindly explain more on the signs.
On the signs, which signs?
Those less than, greater than, why on paper it's less than or equal, then all those down.
Okay, so all I'm saying is that here I'm including negative 2, right? So I mean that down here I'll not include negative 2. If I want, I can include it. But that's why I've not included negative 2, because negative 2 is already included in the first equation. And then here I haven't included positive 2. That's why I've included positive 2 in the third equation. If I wanted, I could have included positive 2 in the second equation also. I don't know if that's okay.
It's okay now.
Alright, and then we'll just get to now look at the signs. So if you look at values of x smaller than negative 2, both functions are what? Negative. So I'll multiply both functions by a negative. Okay, as long as you're talking about values of x less than a negative 2, this function you multiply by a negative, even this function you multiply by a negative. Why? Because both of them are negatives. And then between negative 2 and positive 2, the x minus 2 is negative, while the x plus 2 is positive. So the x minus 2, I'm going to multiply it by negative, this one. This one I'm supposed to multiply it by positive. Okay, and then after or greater than 2, both functions are positive, meaning that both functions multiply them by a positive. Now just simplify this. So I'll distribute the negative, which are about negative times x, that will be negative x, negative times negative 2, positive 2, and then this negative and this negative becomes positive, right? So positive times the x, that will be positive x, positive times the 2, that will be positive 2. This is for x is less than or equal to negative 2. And then negative times the x there, it is going to be negative x, negative times the negative 2, positive 2, and then here negative times positive, that's negative. So negative times the x inside, that will be negative x. Negative times the 2, that will be negative 2. So this is for negative 2 is less than x, which is less than 2. And then here positive times the x minus 2, it will just be x minus 2. And then here I've got a negative times positive, which is a negative, right? Negative times the x, that will be negative x. Negative times the positive 2, it will be negative 2. This is for x is greater than or equal to 2. And then just get to add like terms. You can see this is a negative x, this is a positive x, that are going to cancel. 2 plus 2, that is 4. This is for x is less than or equal to negative 2. And then negative, this is positive 2, this is negative 2, they'll cancel. Negative x minus x, that is negative 2x. This is for negative 2 is less than or equal to just less than x, which is less than 2. And then the next one, this is positive x, this is negative x, they'll cancel. So negative 2 minus 2 to be negative 4. This is for x is greater than or equal to 2. So what we've done, we have redefined the function. Yes, yes, please, Shekaina.
So, Professor, like you were just answering negative and positive.
Yeah, like when you add something which is negative x plus x, it will give you 0. When you're adding something of opposite signs, it gives you 0. Okay, so we can now sketch our graph. Okay, so this is x value. We've got the y value there. So our point of interest, we have got so look at the x values of our interest. So I've got -2. Like when you equated this to 0, found +2. When you equated the other one to 0, found the -2. Those are our points of interest. Okay, but you've seen that for all values of x which are smaller than -2, you always get a 4. As long as you are smaller than -2, you always get a 4. Okay, so the point of starting itself is -2 is the value of x, 4 is the value of y. Okay, remember we're including -2, so we're going to have a coordinate -2, 4 here. That's the point of starting. You always start with the actual one you've been given, that's -2. And for all values of x, as long as it is smaller than -2, it will always give you a 4. So what does that mean? So for all values of x smaller than -2, it will always give you a 4 as y. So it will always be going like that. So you can even put an arrow here. Okay, so I'll simplify. I'll just go also to this one which is down. Yes, Zena.
Sir, why is the line going straight? Why
Yeah,
isn't it slanting?
like every value of x, as long as it's smaller than -2, it's supposed to give you a 4. So if it's -2, it will give you a 4. If it is 3, it will give you a 4. If it is -4, it will give you a 4. -5, it will give you a 4. So it will be a straight line like that, which is not slanting. You get that?
Yes.
Okay. And then for the one down, as long as we are talking about values of x greater than 2, greater than or equal to 2, it's supposed to give you -4. As long as it's greater than or equal to 2, it's supposed to give you -4. So meaning that you are going to have -4 here. Starting with the 2 itself, okay? If you have got 3 to give you 4. If you've got 4 to give you -4. If you've got 5 to give you -4. 6 -4. So it is going to be a line like this. But remember, it's going in this direction. Why? Because we're talking about values of x greater than or equal to 2. And then this one, the -2x, is working for what? All values of x between -2 and +2. That's the one which is working. So you can start with the -2 itself. Okay, you can start with the -2 itself. This one. Put -2 here. -2 times -2, that will give you a +4. So I'm finding a coordinate here, +4. When x is -2, y will be +4. And then get also the +2. Put here. -2 times +2, that will give you -4. So I'm going to have 2 comma -4, which is here. So only have two, you just need 2 coordinates and then join those 2 coordinates. Okay, we're going to join these 2 coordinates like that. Actually, I'm supposed to pass through the center because when x is 0, y will also be 0. So that, this is how the function is going to look like.